Hello everyone, thanks for joining IGBits. We train, you learn. All the aspirants who appearing for JEE Mains Advance uh, and BITS, VAT, all other state competitive exams who wish to secure your positions. Okay, good luck, guys. Definitely you will be able to actually make it. Uh, Thanks for all your efforts you have been putting in gaining the knowledge. This is a place where we have a lot of teaching experience and then expert explanations, things like that. So you can always count on us to take something out of the each the review class that you are making. Today we will be quick starting a final revision uh, on physics. Start with like units and measurements. Okay, let's get started then. Let's recap of what we studied about a physical quantities. A physical quantity is a quantity which can be measured, isn't it? A physical quantity is always measured of a natural non-living objects. So if you look at a physical quantity, it has a numerical magnitude value and then units. Let's say length, mass, time are basically we use for measuring the physical quantity. For example, if the length of the table is 150 centimeters, what that means is 150 is a magnitude, cm is a centimeter is unit of measure. So 150 centimeters means like 150 units of length is what we have for this uh, length of table. Likewise, you can started thinking of like the some magnitude and some units are what we use for measuring the physical quantity, right? Physical quantity does not depending upon any other physical quantities for measurement. Let's say we have length, mass, time are the physical quantities which we don't require to use any other physical quantities to measure. That is how it should be. Physical quantities can be classified as a dimensional and dimensionless the quantities. It can be a constant, it can be a variable, things like that. So fundamentally, if you look at how to classify the physical quantities, we have fundamental physical quantities are the base quantities, we have a derived quantities, we have a supplementary quantities. So just now we looked at, right, the fundamental quantities, basically the physical quantities does not depend on any other physical quantity for its measurement is what we known as a fundamental physical quantities. If you look at a derived quantities, where physical quantities which express in terms of a fundamental quantities are known as a derived quantities. Means for the derived quantities we use a fundamental quantities which is of like length, mass, time, etc. There is one more classifications which we studied is like a supplementary quantities. Plane angle, a solid angle is basically classified under supplementary quantities, right? If you look at a fundamental quantities, mass, length, time, temperature, electric current, luminous intensity, amount of substance are the fundamental quantities. So we use mostly for mass, length, time for representation of a physical quantity, but there are the physical quantities which also requires electric current and luminous intensity and amount of substance. So the primarily we can focus on these 7 physical fundamental quantities is what we use to determine you know uh, all other physical quantities which is of what we can call it as a derived quantities. Okay, let's say for instance velocity we all studied, right? Velocity means like what? Displacement by time. So displacement is nothing but a length, right? And then time. So length by time is what we say is velocity. So length and time are a part of your fundamental quantities, which is of length, mass, time. So velocity, which we measure in terms of length and time, that means like velocity is a derived quantity which is being derived from the fundamental quantities. We are expressed in terms of fundamental quantities, isn't it, right? Similarly, we have acceleration. The definition of acceleration is change in velocity, right, by time, rate of change of velocity in a way. So it's not, it's ultimately you can say velocity by time is what the acceleration means, right? So velocity is again a derived physical quantity, and then time is from fundamental quantity. So in a way, if you look at all derived quantities can be expressed in terms of fundamental quantities, right? So when you talk about units of fundamentals are fundamental units. Units of derived quantities are known as a derived units. Both fundamental units and derived units are known as a system of units. All right. So we have CGS system, FES system, MK system, and SA system, which we can look at little more in details later. In earlier time, the scientists of different countries used different systems of units for measurement. Three such systems: the CGS system, FES system, and MK system. FES system is also known as a British system. So these are the systems which extensively we use in day and day out. The base units for length, mass, time, okay, in these systems were as follows. That is what you are representing. In CGS system, they were a centimeter, gram, seconds. Right? So mass measured in terms of grams, length means centimeter, and time is a second. In the FEA system is also known as a British system. That's what we discussed, right? We use like a foot, pound, second. In the MK system, we use meter, kilogram, and second. If you can look at, C stands for centimeter, G stands for gram, S stands for seconds. That's why CGS system. FES means F stands for foot, and P stands for pound, S stands for second. So FPS is also known as a British system. MK system means meter, kilogram, seconds. SA system is an international system of units. So we use like a different, these measurements in different countries. But ultimately, we need to understand what these systems do, right? These systems we use for actually measuring length, mass, time are expressing all other physical quantities in terms of length, mass, and time. This is what you're saying. There is a conversion because the units, the probable for each system is like different. So you should be understanding like what is the value that is given and in which system, and then ultimately whether you're going to use the same system of units or you will be actually converting into the other system of units. That caution that you have to be prepared for it. Okay. Let's look at dimensions and a dimensional formula. The dimensions of physical quantity are the powers to which the base quantities are raised to express that quantity. Isn't it right? I'm repeating. Dimensions of physical quantity are the powers to which the base quantities are raised to express that quantity. Okay, whereas the expression which shows how and which base quantity represents the dimension of physical quantity is known as a dimensional formula. Okay, so let's say for instance velocity, can you define the velocity? Velocity is nothing but displacement by time. You're right. Displacement we measure in terms of length and time in terms of seconds. Our notation would be L by T, right? If you can look at L to the power of 1, T to the power of 1 is what we can express, right? When we write in velocity, velocity is nothing but L to the power of 1, T to the power of 1. This is what we are saying, to the power. The physical quantities, we are actually raising the powers of the base quantity. L and T are the base quantities which we studied, isn't it? Are we depending upon mass? No. So that's why the base quantity mass, if you wanted to represent in your dimensional formula for velocity, what we do is like you're raising the power to 0. Mass to the power 0 is what we say. That means like we are not depending upon the mass. So L to the power of 1, T to the power of -1. So ultimately the velocity, the dimensional formula for velocity is m power 0, L power -1, T power -1. M, L, T are the representation of base quantities. Let's look at force. We know that force means like m into a, mass into acceleration. Mass means like m, so m to the power of 1 is what we have. The m, our base quantity is like m, and then we are raising the power to 1, m power 1. Whereas an acceleration is nothing but velocity by time, or the displacement by time scale. So we know the formula, right? The dimensional formula for velocity divided by 1 more t. So that means we are raising a reciprocal power of t is 2, so t power minus 2. So m power 1 l power 1 t power minus 2 is the dimensional formula for force. So likewise we can express all our physical quantities in terms of a base quantities. Okay, uh, you know, so this is how I think we can, you can experiment it and then try to extract more formulas, and then dimensional formulas, representations and all. Okay, I hope you're clear, right? Thanks. Yeah, let's move on next topic. So we have a typically like what sort of the questions that we may see, right? So let's look at a sample example. The dimensions of frequency is, so we need to understand like what is the formula for the frequency. So that actually gives you a feeling when you say the frequency, right? So it is nothing but a reciprocal of your time, correct? So that means like we have only depending upon the time, so we are not depending upon mass, we are not depending upon length, but we do depend upon time, the t power minus 1. So by looking at this, we know this is a dimensional formula for the frequency. So if you look at your options, t power minus 1, t power 1, so this is wrong, and then t power minus 2, no, none of the above are the t power minus 1. So you is t power minus 2 is nothing but m power 0 l power 0 t power minus, so this is the right answer. So guys, let's guess this question, the dimensions of wavelength, and then we have the options here. Who is going to answer? That's correct. So wavelength, right? So wavelength, which we, how do you represent wavelength in terms of length? So now we know the story, right? So what you are saying is that, so wavelength, wavelength you measure in terms of length. Good. So that means like you are depending upon only l to the power of 1, right? So what is absence here? M power 0, l power 1, t power 0. So if you can look at this, would be your answer. So m0 l t0, so option B is the correct. Obviously these are wrong, this is wrong. So since we have an answer, none of the above are also wrong, right? So your answer would be option B. Good. These are the typical questions that we get in the dimensions. There are many, but we'll see one by one. Let's look at the next one. Here, the given dimensional formula, but we need to relate which quantity it should represents, right? So that means like we need to look at like each option and then figure that out, you know, which is actually the right fit for it. M power 0, L power 1, T power minus 2 is what is given, isn't it, right? Displacement means like only length, but you also have like a T. So obviously this is a wrong answer. Now you look at velocity. Velocity means like displacement by time. So we have only, so velocity is nothing but your displacement by time. So displacement we measure in terms of length, so length by time. So L power t power minus 1, right? So but we have t power minus 2. So probably you look at an acceleration, right? So if your acceleration equal to what? Velocity by time. Velocity we know L power minus 1, t power minus 1 divided by t power 1. So L power 1, right, and then t power minus 2. is what is given. M is also 0. So now m0 L power 1 t power minus 2 would be acceleration. So answer is this one, right? So if you ask like representation of a dimension formula for the given physical quantity, and the second method would be for a given dimension formula, we have to see like which physical quantity that you can relate it. These are the two different kind of a problem that you may see in your exams. On a simple note, let's look at some of the dimensional formulae of a physical quantities. So we have listed like an area, volume, mass density, frequency, velocity, speed, acceleration, force, impulse. So likewise you can have like an all other physical quantities. By now I think you might already covered one snap of like an complete the physics. So you should be remembering all the formulas for the physical quantities. If you are thorough enough in the physical quantities and their relationship, and then obviously you should be able to actually recall like how to represent a dimension formula. Let me quick walk through a few. So let's say area. We know length and breadth is nothing but a representation of area. So length and breadth both are basically like a base quantity is like length only. So L into L square. So m power 0 L square t power 0 is what our dimension formula for area. Similarly, if you look at a volume, so for volume, length, breadth, height, right? The product of all three is what the volume means. So length into length into length is what our representation dimensions, right? The dimension for length is L, dimension for breadth is L, and the dimension for height is also L. So L into L into L, L cube. So m power 0 L cube t power 0. Make sure when you are only depending upon L, then obviously like the base quantity mass and then times both represent say a power zeros rising to the 0 power. That's what we are representing. So we don't require m and t for representing volume, right? Let's look at next one, mass density. So how do you represent mass by volume is nothing but a mass density. Mass means a physical quantity is m, so m to the power of 1 is what you represent as a dimension, right? The volume just now we see is L3, m by L3, so also known as m L power minus 3, right? I think there is a typo here, we have to represent it. Right. Next one, the frequency. Frequency means 1 by time period, so 1 by t power 1 or also t power minus 1. So m L are independent when you are looking at a frequency. So m power 0 L power 0 t power minus 1. Agree? Okay. Similarly, you look at a velocity. Velocity means displacement by time. Displacement, dimension for displacement is what? L. Dimension for time is t. So L by t is what your dimensions for velocity, right? So if you can make it like a formula, m power 0 L power 1 t power minus 1, because velocity is not depending upon mass, and hence mass power always 0, m power 0, right? Your rising power to the mass is 0. Let's look at a speed. Speed is nothing but distance by time. Distance, dimension for distance is like what? L, length. Dimension for time is t, seconds. So L by t1, L1 by t1. So we are independent of mass. So m power 0 L power 1 L power t power minus 1. If you look at the dimension of velocity and speed, both are same. So velocity and speed has a same dimension formula. Sometimes you will get a questions like this. Okay, which are the two physical quantities having like a same dimension formula? This is how we have to look at. Okay, so by definition, in terms of dimensions, both velocity and speed are same, except there is a scalar vector in a differentiation that we studied already. Let's look at now an acceleration. Acceleration is nothing but velocity by time. You know the velocity dimension formula, m power 0 L power 1 t power minus 1 divided by t, means like you are rising t to the power of 2, right, in the denominator, or t to the power minus 2 otherwise. So m power 0 L power 1 t power minus 2 is a dimension formula for acceleration. Let's look at a force. Force is nothing but mass into acceleration. Agree? So So mass base quantity, right, to the power is 1, m to the power of 1 into acceleration we just we derived m power 0 l power 1 t power minus 2, put all together, what we get is like m power 1 l power 1 t power minus 2. Agree? So similarly you look at the impulse. How do you define impulse? Impulse is nothing but a change in momentum, is also known as a force into time. So if you know force dimension formula for the force which we derived previously, m power 1 l power 1 t power minus 2 multiplied by one more t is nothing but m power 1 l power 1 t power minus 1. So what we are trying to understand here, if you know the physical quantity definition, means like relationships with other physical quantities, then you will be able to not, easily recall the dimensions of each physical quantity and then create a dimension formula, derive the dimension formula of that physical quantity. So you have to understand the formulas and dimensions and how you gonna extract the dimension formula from that relationship to represent the physical quantity in terms of dimensions. This is what we studied in physics. We have many the concepts, right, regarding the physical quantity. So you should be able to figure out how to represent or derive the dimension formula for each physical quantity. There could be typically like 1 or 2 questions on this topic, so you make sure you're thorough enough to understand these formulas. Any questions? Okay, no problem. So we can continue the next topic. In previous, actually, we studied we looked at a dimensional equations, right? The dimensional equations can be obtained from equation represent the relationship between the physical quantities. The dimension formula of a large number of wide variety of physical quantities derived from equation represent the relationship among other physical quantities and expressed in terms of base quantities, mass, length, time, right? So now we are doing all these things, but why? So what is that secret behind the dimension analysis? There should be an application, right? What we say that here, dimensional analysis helps in deducing certain relationship among different quantities. That's what we are trying to get it. The applications here is to check the correctness of given a physical equation, isn't it, right? You have the equation of uh, of physical quantity, but we don't know the correctness of the dimension for each and every term which participated in the equation, right? So this basically helps you. The second thing is like to convert the physical quantity from one system to another system. That is also the place where you use a dimensional analysis. So for instance, to convert the physical quantity from one system to another, typically this is the formula that we use, right? We can look at the few examples later, but you can remember for now, right? Homogeneity of dimensions. Based on this principle, a correct dimensional equation must be homogeneous. What this means, dimensions of all physical expressions in this equation must be the same. So dimensions of LHS and the dimensions of RHS, left hand side of the equation versus like a right hand side of the equation, should be the same, is what we are going to check in the homogeneity of dimensions. If the both dimensional formula and in the expression, in the equation for each expression are same, then you say that like your formula is hold good. Otherwise, the probably I think your equation is wrong. Things like that, right? For instance, like we have an example, velocity v is equal to u plus cat. V means like a final velocity, u means initial velocity, and then a stands for acceleration, t stands for time, right? So let's look at whether this equation is correct or wrong. So correct or incorrect. So what is the dimensional formula for v? So we derived, right? Velocity is nothing but displacement by time. So displacement is nothing but like an L representation in terms of length. So length by time is what we get velocity. L power 1 t power 1. L power 1 by t power 1. M is an independent here, right? We are not depending on the mass. So totally m power 0, L power 1, t power minus 1 would be your dimensional formula for velocity. So velocity is a final velocity or initial velocity remains same, no? That's why. So keep the left hand side of total dimension formula aside. Look at right hand side. Right hand side, what we have? U plus at. Let's look at each one separately. U means initial velocity, and then the dimension formula for initial velocity is same as like a final velocity. So you can represent m power 0 L power 1 t power minus 1. Good. Now let's look at the AT, right? AT, acceleration into time. The dimensional formula for acceleration, we know that m power 0 L power 1 t power minus 2. If you don't remember, then what you have to do is like velocity by time, right? Acceleration is nothing but rate of change of velocity, velocity by time. We know the velocity, dimensional formula for velocity divided by time t. So what we get is like m power 0 L power 1 t power minus 2 and multiplied by time t. That is what AT means. So what we get is m power 0 L power 1 t power minus 1. If you look at each and every expression in this equation has same dimension formula, and hence you validated the homogeneity of this equation, which is right. This is the one application of using this concept to check the correctness of the equation. Accuracy, precision of instruments, and errors in measurements. I think we studied this part again. Okay, let's recap. Measurement is the foundation of all experimental science and technology. The result of every measurement by any measuring instrument contains some uncertainty. This is what we can call it as an error. Every calculated quantity which is based on measured value, right? The measured value may also have an error. So how you're going to distinguish them, right? So we need to understand the concept of accuracy and precision, the meaning of it, and then figure that out. What is the true value, and then how many times it repeating same consistently, what do we get, things like that, right? So let's see. But there is so when you say errors, right, we have to look at one thing is like what is meant by systematic errors, right? Errors are systematic errors, random errors, and the least count errors. So systematic errors are those that are tend to be in one direction, either positive or negative. Right? Some of the source of systematic errors are instrumentational errors, and then imperfection in experiments, techniques, or procedures, or personal errors, like parallax errors. So this is what I think we can call it as systematic errors. Another topic that what we can study is like a random errors. So random errors are those errors which occurs irregularly, and hence we can call them as like a random behavior, right? Random with respect to sign, size, that sort. So we look at a least count errors. Yeah, so we know the least count, right? Least count means like a smallest value that can be measured by the measuring instrument is nothing but a least count. So while reading that value, probably you may read, with some error. So that's why we need to understand the least count error also. So the measurement is very important than measuring to the true value by minimizing error. Minimizing error is also important. That's why this topic is very important, is what we studied. We may get like in the few questions on this topic too. All right, let's look at the few definitions: accuracy, precision, resolution, and least count. Accuracy means the physical quantity measured by the measuring instrument resembles very close to the true value. This is nothing but an accuracy. You have to understand, right? Physical quantity measured by the measuring instrument resembles very close to the true value. So that means, let's look at in one example. You are trying to actually measure the weight of some substance. Let's say you measured it and then you got a 4.5 kgs is what you get in the measurement. But actually that the weight of the substance is like a 7.5 kgs. You think of like too much of difference, right? The deviation from actual versus like the true value. So I mean objective measured value versus like a true value. So then your measurement is not accurate. That is how you say the accuracy means. Your measurement is not close to a known true value, is what we can understand the meaning of accuracy. Are you clear, guys? Now look at a precision. What is meant by precision? If the value measured by the measuring instrument remains unchanged large number of times, okay, it may have repeated. So let's say you are doing this measurement repeatedly. If you are able to get a consistently same outcome of all your experimental measurements, then you can say like your instrument is actually giving the precision value. The precision and accuracy both are different. You have to be clear on that. So accuracy basically tells you like how erroneous that the measured value given by the instrument is what you can see. But precision means like at least of for sake of understanding the how instrument works, either the instrument is giving a consistent result for all your experiments. The precision refers to the closeness of two or more measurements to each other. That is how you have to distinguish. Clear, no? Now let's look at a resolution. Resolution stands for a minimum reading that the instruments can read, right? A resolution refers to a smallest change in the value that the instruments can detect or display is what we can define as a resolution. So these are very a tiny difference if you don't understand fully, but these are very important in in understanding how a measurement can be done using measuring instruments, right? For example, if a digital pressure gauge has a resolution of 0.001 psi, it will be able to detect and display the change in the pressure as small as 0.001 psi. That is what the resolution means. High decimal values, if you see, that means like more accurate that you can think of it, more resolution you can think of it. So what is mean by least count? The least value that can be measured by that instrument. For instance, you have vernier caliper and then screw case. Both have a different least counts that you can get the concept while doing some examples on that two instrumentation. So what we studied about the least count? The least count of a measuring instrument is the least value that can be measured using that instrument. We have the vernier caliper, we have the screw gauge. So what is the definition of least count for the vernier caliper? The value of one main scale division divided by a total number of divisions in the vernier caliper is what the least count. Whereas in screw gauge, the value of one pitch scale reading divided by total number of head scale divisions is what the least count. Okay. We will see like more in while doing examples. This is one more very important topic, how you are going to calculate the magnitude of errors. Okay, we have to understand the few definitions and then how you're going to arrive them. Let's say the true value, so it means the observed values, right? So what is meant by mean? If you have observed values like a1 a2 a3 till an, then mean means like average of all the observed values, a1 plus a2 plus a3 till an divided by number of observations, just like n. We can also represent something like this: 1 by n, a sigma k to the k from 1 to n for a for k is what we say. A1, A2, A3 are the observed values and n is the number of observations. So you try to get the mean of the value. Now what is meant by absolute error? So since that I think you calculated a mean, what you have to do is like you have to subtract a mean value, I mean all the observed values from the mean value or vice versa. Since you are getting like an absolute error means like you have modulus of your delta is what you are going to get. So observed values, if you can sum them all, you'll get like an aggregated error for the observations. All right, let's see like the few more definitions for this calculation of magnitude errors. Mean of absolute error, mean absolute error, MAE, the arithmetic mean of magnitude of different values of absolute errors. So like a delta A1, delta A2, delta A3 till delta A1, right? These are the basic like in your absolute errors. Sum them all and then average it. This is what you mean by mean absolute error. So when you have like an observations, you can easily understand like how to calculate mean, how you would be calculating the absolute error and then mean of absolute error, right? Now the question here is, what is meant by relative or the fractional errors? Since that you know that mean of absolute error, what you have to do is like mean of absolute error divided by mean value of measurement is what you determine when you are calculating the relative error. Relative error means like delta A mean by A mean. Percentage of error means like same thing. Relative multiplied by 100 is what you get like percentage of error. Alright. You know that concept of mean, absolute error, mean absolute error, relative or fractional error, and percentage of error. So we typically we will get like in a one or two problems on these concepts. Make sure you have to recap all these formulas and then try to do like the few examples, part of your practice, and then try to be confident on getting right answer at place. Okay, let's look at this problem. Guys, come up with an answer. Reading of successive measurements of period of oscillations of a simple pendulum is given. Right, some observations are given here like 2.63, 2.56, 2.42, 2.71, 2.80. So they're asking us to calculate absolute error, relative error, percentage of error. I will pause for a minute. I think you people just come up with an answer and then we can discuss. Excellent, excellent, very good. Actually, I think some of you guys already, you know, uh, solved it. Very good. So this means like you guys understand the problem, right? I thought I wanted to give you a homework, but you already completed. That's good. The revision class is going good. So what we are saying is like in order to get an absolute error, what is the first thing that you have to do is like mean of your observations. So mean means like average of given observations, like sum of all the given observations divided by number of observations is what you get a mean. So we got a 2.62 is what mean. Now you have to calculate an absolute error, right? So we know that, right, delta of each observation from the mean, and then sum them all. So 2.63 is an observation minus 2.62 is a mean. So that is how I think you will be, calculating all the absolute errors and then summing them all. So there is no negative. We have to take an absolute value. That's why modulus. So modulus of 2.63 minus 2.62 is what you get the absolute error for this observation. And then for 2.53 minus 2.62 for the second observation, 2.42 minus 2.62 is a third observation, 2.71 minus 2.62 is a fourth one, 2.80 minus 2.62. 2.62 is repeating, right? This is a mean value. We are subtracting a mean value from the observations, and then modulus operation basically gives all the positive values. Summing them all is what you get like a 0.54 here. And then what we needed is like a arithmetic mean of absolute errors, mean absolute error. So means sum of the absolute error divided by number of observations. So 0.45 divided by 5. 5 is what is given, right? 5 observations. So what you get is 0.11. So how do you read this one? The period of oscillations of a simple pendulum can be seen like this: 2.62 plus or minus 0.11 is what a correct representation of what we get here, right? This is a concept of absolute error. So how do you calculate a percentage of error? Can you think of? So percentage of error is basically like your relative error divided by, relative error multiplied by 100, isn't it, right? So we know that relative error means, right? This is what is called as your relative error. Mean of absolute error divided by mean of mean value of measurements. Mean of absolute error, what we get is like 0.1, and your mean value 2.62. So roughly I'm taking 2.6. This is what you can call it as the relative. Multiply by 100. So what we get is approximately 4 is what your percentage of error. Are you clear? Very good, guys. So last topic for today's revision class is the propagation of errors. Right. So let's say delta A means like an absolute error in measurement of A. Absolute error in measurement of B is, let's say, delta B. Absolute error in measurement of X is delta X. Let's assume this way. So now your equation would be X is equal to A plus B. How do you calculate error in sum of the quantities? So if you know the delta A and delta B, all you have to do is like summing them to get the net error of dx. Dx is nothing but now plus or minus delta A plus delta B is what you get it. Right? All the time like you will be adding the errors, both in case of like in a sum and a differentiation, subtraction, basically. Right? So suppose you have your equation is like x is equal to a minus b. So the how do you calculate error? Dx is equal to plus or minus delta a plus delta b. Don't subtract the errors, please. Okay, you have to always add them, because that is the error that you will be getting. Okay, error in the product of quantities. So let's say you have equation is nothing but like x is equal to a multiplied by b. What you get is that delta x by x is what you are trying to calculate the error, for which delta a by a plus delta b by b is what you can get the error in product of quantities. Similarly, error in division of quantities. So if your equation is x is equal to a by b, then what you will get it, both division and then subtract less, you have to do like the same math. Dx by x is equal to plus or minus delta a by a plus delta b by b is what you supposed to get, right? Okay, this is a propagation of errors. There are the few examples. You can refer them, or else like in the next class we will be reviewing them. Okay. Okay, let's look at this problem. Who is going to solve first? Let me read out. The temperature of two bodies measured by a thermometer are T1 and T2. We are given T1 and T2 observations including errors. 20 degrees centigrade plus or minus 0.5 degrees centigrade is T1. T2 is a 50 degrees centigrade plus or minus 0.5 degrees centigrade. T1 and T2 is given. What was asked? Calculate the temperature difference and errors in there. Okay, temperature difference, right? How do you calculate? The main value should be subtracted, error should be propagated, right? Error should be propagated in the sense like error should be added. That is how it should be. Okay, that is a hint that is you have to use for this calculation. Let me do it. A temperature difference at T is nothing but a difference of T2 minus T1, that we know. What is given? T1 50 plus or minus 0.5. Okay, minus T1. T1 how much? 20 plus or minus 0.5. So what you should be doing, the main values 50 and 20 should be subtracted. 50 minus 20 should be subtracted. There is no change. However, the error should be added. So plus or minus 0.5 plus 0.5. So now what you get it? 30, 20 minus 20, 50 minus 20 is nothing but 30. The plus or minus 0.5 plus 0.5 is like 1.0. This is what your answer. 30 plus or minus 1.0, right? So degree centigrade, I mean. The value varies from 30 plus or minus 1. So 30 plus 1 to 30 minus 1. So 31 to 29. I mean 29 to 31. Right? This is the value. Alright. Okay, let's look at this problem. The resistance R is equal to V by I, where V is voltage. The given is 100 plus or minus 5 volts, and I current is 10 plus or minus 0.2 amperes. Find the percentage of error in R. Okay, how do you calculate this one? First we have to understand like a percentage of error in V, percentage of error in I. Okay. So percentage of error in V. How much? Error is given 5, but we have 100, no? So totally 5%. That's nice. Now look at percentage of error in current in I. How much we give it? 0.2 error for the total value 10. So what is you get it 2 by 100. That means like 2%. 2%. So now total error in R. Total error in R should be sum of two errors. So 5% plus 2%. So which is nothing but your 7% would be your answer. Right? We are closer to the end of session. Thank you all once again for joining today's session at IG Bits. Thank you. Good luck for your preparation. Stay tuned to next session. See you tomorrow. Okay. Have a good day. Bye bye.